So I'm going to talk about some ideas related to open in the education space in particular, and talk about the ideas of open educational resources, open source software, AI ideas, and also like open research. And I'm going to tell this by way of a story, kind of my 26-year story in this world of open, and hopefully it'll make things more interesting to have that narrative, and then we'll hang some of the big, I think, key issues facing us in the past and today along the way. So hopefully that's okay with everybody. I'm just gonna get a box out of the way here. Okay, perfect. So, oh, just a second. I'm gonna have to just restart my share because I have oh, that's gonna work. Okay. So let's rewind all the way back to 1999. I don't know what you were doing in 1999, but in 1999, I was teaching a course, and it was a signal processing theory course in the Department of Electrical and Computer Engineering. Uh, that's my original career was as a faculty member in an electrical and computer engineering department, and I was teaching a course that I really thought that this was you know, really, it was my course, and so I really thought it was great, and I thought that it really addressed these ideas of Fourier analysis from multiple different angles. There was something in it for everyone. We talked about applications, we talked about theory, we talked about big issues facing the engineering world at the time, and so you can imagine I was a little bit surprised when I looked out over the audience and, this is what I'd see. And it really bothered me, right? Students in the back reading the newspaper, uh, other students kind of, working on homework from other courses. And I resolved to do something about it. And what I did was I took advantage of the fact that Rice University, was and still is a really small school. Just a couple at the time, about 2,500 undergraduates. And I had about 20 students in my class. And so what I did was I hauled the all the students into my class who were having uh, who were not paying attention. And I tried to haul them into office hours and ask them to do, psychoanalysis with me. Like, why were they not interested in this particular class? And what I found kind of really astounded me. I learned so much about learning uh, at through that period. I also learned about all kinds of different teaching techniques, which I had never ever been exposed to and that I could go about trying. And I also realized that there was no way that the course materials that I had available for my course were going to work for all the wide breadth of the students in my course. I had students who were interested in being policy people, going into government. I had folks interested in becoming digital recording engineers. People wanted to work on digital cameras, communication systems. And there was just no way that all of those students could be excited by the material in just one set of course notes. And so I thought, okay, let's have a look at the course materials that are out there, and see if we can move beyond, one size fits all. And again, what I saw astounded me. These are actually the seven main books at the time that folks were using to teach this particular course around the United States and Canada. And they were basically carbon copies of each other. Okay. So much so that if you look, every single book has a mountain on the cover. Okay. And this struck me as an area that was maybe ripe for, commoditization or ripe for innovation. And so I sat down, to think, and, I had an idea. And my idea way back in 1999 was that maybe we shouldn't be focused on course materials from like a one size fits all textbook, but think about knowledge as more like an open web, if you will. That happened to be when the World Wide Web was just really exploding in use. And so I had this then crazy idea. Wait a minute, let's take all the world's textbooks and rip the pages out, right? So that they can be modularized, turned into Lego blocks, and then they could be put together, pieced together in all kinds of different ways to make, powerful learning machines for people, right? And just like Lego, very quickly reorganized to create, different kinds of learning machines. So that was the first idea that I had. The second idea was around the whole intellectual property enterprise and realizing that the only way to really have content that could be Lego bricked like this and really made available to mix and match is if we change from the standard copyright regime to an open regime, right? Something based on open source software, which at that point in time was also really starting to take off, right? So think of these pages in these books as maybe contributed by a community with altruistic means, licensed with an open license. The Creative Commons actually didn't even exist back then, but then they came along in 2002. And in that way, we can also make everything completely free so that we can make these really great learning experiences available to everyone. And available not again in this one size fits all form, but in a truly personalized form where every student can get their own set of course materials, right? Their own book. Okay, so this was the idea that we had. We started a project, we called it Connections. It was one of the first open educational resource projects, OER. Other ones that you might remember from back in the day, MIT OpenCourseWare, and certainly Wikipedia all came around at about the same time. And it's just really exciting, to be here today to just think about how far this world of open access has come in these past 2.5 decades or so. Okay, so that's the base idea that I was thinking about at the time, which is liberating the ideas from all of these monolithic textbooks. So now let's fast forward about 12 or 13 years from then, and we were confronted with a real issue, right? And the issue is that the United States and Canada and other places had just come out of the Great Recession that started in 2008. Uh, many folks lost their jobs. Many folks looked at going back to college to retool, to pick up new skills, to be able to get back into the workforce. And they found that it was becoming extremely expensive, right? And certainly tuition was part of it, but the other really big part of the cost of going back to college was the skyrocketing cost of textbooks. Okay, and this chart really says it all. That over the from about 1974 or so to about 2014, you can see that the price of educational books grew about 1,000%. Okay, and that's faster than any basket, right, in the consumer price index. And so the phone was literally ringing off the hook uh, at Connections with instructors saying to us, I'm a physics instructor at this college. Uh, my students can't afford the textbook. It's $300, so they're not buying it, and so they're getting lost. They have nothing when they go home at night to study with. They're not completing even the first homework, and they're dropping out. And so we really hoped that we could do something for these folks, but we were much more in those days in the business of building this vast repository of Lego blocks more than directly some kind of solution that could help these folks. And so we decided in 2012 that we would pivot, and we would pivot to try to scale up the use of OER by bringing it into the mainstream, and to continue with this repository of these Lego bricks for teaching and learning, but basically configure them into standalone textbooks, which at the time, right, 2012, people were still using PDF and print textbooks that were basically turnkey, uh, turnkey adoptable by instructors across the United States, across Canada, and around the world. So basically, really, really high quality, authored by top people in the field, complete sets of problem sets, solutions, end of chapter problems, test banks, PowerPoint slides, etc. So we basically took all the ideas we had developed from this open source kind of learning and applied it to basically the take on the publishing industry. And it's just been really fun. Fast forwarding to this year, we just finished our 85th textbook. These are all born digital books. They're actually, if you look, peek inside, peer deep inside them technologically, they're all based on these Lego bricks. But when you look at them externally from, say, the OpenStax website, they look basically uh, totally comparable to anything that is put out on the market by the standard, big publishers. We basically cover most of the courses in the first 2 years of college now. You can just browse through some of these titles, all the big courses, calculus, chemistry, psychology, government. We also cover an increasing number of K-12 courses, in particular in high school. And we've just really been excited by the growth over these last 13 years. We're now the number 4 publisher in the US textbook market. We're used this school year by about 7 million students. These are like real students using OpenStax as their primary learning materials in a course that's been adopted by their instructor. And really excited that we just recently passed through $3 billion in savings for students. Why? Because these books aren't just open source, they're completely free, right? We don't sell the books for $300. We make them completely free. And with the idea that we're trying to provide really increased access to get for students so that they can succeed in the topics that they want to learn about. We've seen just a really interesting stabilization of this exponential growth curve that I talked about a few minutes ago. You can see college textbooks here. The prices have really stabilized over the last number of years. And really, this is really attributable to open educational resource projects like OpenStax. And I would liken it a little bit to use an American metaphor. It's a little bit like what's called the Southwest Airlines effect, meaning any airport that Southwest Airlines flies into, they always had to have the lowest fare. And so what they did is they just pulled prices down, right, for anyone flying out of that airport. Okay, and it was basically good for the world. I guess it'd be a little bit like WestJet in the early days. So this is all some great progress. I think it's too early, right, to say mission accomplished. Wow, do I ever miss that guy? Uh, because we're moving kind of from crisis to crisis. So I would say that this is we've made some really good progress on access and increasing the amount of access for folks to high quality educational opportunities. But what we're moving into now is what I call the attention crisis, right? And in particular, the fact that you can make the world's best textbook and other materials, and people are not going to read. Students are not going to read these materials. You're going to sign chapter 7 in your book. It's not going to happen, right? Students are basically going to adopt completely different study strategies than many of us had when we were going through college. Uh, and so this I like to kind of summarize this in kind of like a set of quadrants, right? So instructors, like many of you and like me, will assign readings to students. We're going to assign maybe videos to watch, other activities to interact with. And the kind of activities that we're envisioning, you can think of as living as in the upper left quadrant of this this world, where vertically, as you go up, you get to higher quality learning opportunities, right? Deeper learning, more effective learning. And as you go to the right, it's a little bit strange. Go to the right, it's time saved. So it's like less time to the right and I guess more time to the left. So just because of this classical way of a traditional way of educating, we tend to think that students are going to spend a few hours a week doing the activities that we recommend, and then they're going to work on their homework. Okay, that doesn't happen anymore. Students basically shortcut, right? They'll not read, go right, typical thing. They'll not read anything that you provided. They'll go straight to the assignment, and they'll type the problems into Google, right? And then they'll hit search, right? And then they'll look for clues, right, that they could use to solve their problem. I'm not suggesting that they're doing this to cheat. They're just doing this because they're just saying, well, this problem somehow involves, some kind of physics problem of a trajectory of a cannonball shot out of a cannon. And so let's go on the web and try to see if see if I can find some way to bring me up to speed quick enough so that I can answer this problem and then move on because I'm really busy, right? And I'm really busy, have a shorter attention span, and I just want to move on. Okay, so this kind of shortcut to learning, it's really interesting. There's a sort of a Socratic aspect to it, sort of, in that students are really motivated to go find, right, something on their own to help them solve a problem. But ultimately, the materials that they pull together, the learning experience that they pull together, just ends up fragmented, right? Inefficient in the end, and really ineffective. Okay, and so what we aspire to in this next generation of thinking about what we're doing with OpenStax is, just thinking is there a way that we can get into this upper right quadrant, right? Is there a way that we can get in there where learning quality is higher? Students really learn more effectively, more deeply, have better retention, but uh, there is some amount of time savings for students, right? So that they actually do this, right? Rather than staying in the bottom right quadrant. So what we're doing at OpenStax is like a lot of other publishers and institutions are doing is moving from a publishing type model. In our case, we have our OpenStax repository of content. We compile it together into digital textbooks, and then students read them in kind of a passive experience, right? That is becoming less and less interesting to students. Moving to a teaching and learning platform kind of approach, where now OpenStax, you can think of it as this nexus, right? Where students are going to actively learn. They're not just might just not be reading, might not just looking at videos, not just interacting with simulations. They're actually doing their homework there. The instructors are there, uh, and they have access to all of this content from this repository. Once you set up a system like this, it's also very straightforward. Unlike with a regular analog or digital book, it's much simpler to insert really meaningful AI expertise, right? AI assistants of all kinds that can help instructors instruct, teach more effectively, and also help students learn more effectively. So this is this paradigm of moving from a publishing type enterprise to a teaching and learning type enterprise. And if you think about the requirements for this of the kind of AI that might be involved, right? Is that we might think about, right? Involving students in the process, instructors in this system, but also be able to have a whole variety of different AI curated and even generated lessons, right? Let's, I'm not saying this exists. I'm saying this is a hope, right? If we can do this, we could hopefully have a set of requirements for these AI curated and generated experience that are such that they're time efficient, right? Students learn, but they learn in less time. They're really personal, meaning personalized to the student's context. They're engaging. They involve multimedia. They have real-time support when students get stuck, and maybe most importantly, they're like end goal focused, meaning students can really see when they enter into these learning experiences how they're actually going to help them on their particular homework, which is really the key to getting them to actually engage with these. Okay, and as you might imagine, OpenStax, we're building a number of our own AI tools in order to attempt to do this kind of thing. We're also working with and outside of OpenStax, all kinds of companies are now moving into this space, not just small ed tech type companies, but now the big three AI companies have all introduced major steps into the education space. Uh, and they're signing up universities and colleges to be using their tools, help them build out make the tools even more appropriate for education. And we're just going to be seeing more and more and more of this. One thing, I'm not going to talk too much about open source today, but one thing that would be nice, right? Nice is if we didn't have to rely on only these proprietary big business AI companies to provide the assistance we need in education. Wouldn't it be nice if we also had, open source AI type approaches, right? There's, limited progress in this space, uh, but uh, uh, but still tremendous amount of work to be done. And when I say open AI here, I mean a space, right? I don't mean the company Open AI, which is not open. I mean real open source ideas around AI. And this is a big issue we could talk about later in the questions. But this is I think an issue that's going to be facing colleges that we're moving from proprietary content from the publishers to proprietary AI tools from these big companies. Why are we adopting these big AI models that these companies and others are offering? Well, they have really compelling offerings, right? One is these models have been trained on so much data and so much educational data that they're really unparalleled in integrating knowledge across fields, connecting chemistry to physics to calculus to humanities in a way that can be, really engaging for students, right? Speaking of engaging, these experiences can just be extremely, students just seem to really gravitate to these AI-based experiences. They're persuaded increasingly by AI. These AI systems have a really great bedside manner. Students are falling in love, right, with their AI systems. And so, we're just going to see more and more of these, AI type tools being integrated into campus experiences, into experiences on, learning management systems, and into, digital educations and the actual teaching enterprise. But I don't want to be all, Pollyanna about this. There are tremendous challenges that are facing us as we move into this space uh, around equity, bias, around attribution, right? There's all kinds of lawsuits going on now around folks, authors whose content has been used to train these AI systems. And we'll talk about some of these others as we go along. And so this is really a polarized space where there are, AI boosters on the one side, AI naysayers on the other, uh, and then not too many people in between. And I think it's just going to be a really interesting next few years as we try to build bridges between these two camps and figure out a really productive and responsible way forward with AI. And so in the spirit of that. The folks on the two ends of the spectrum. Let's just spend a couple minutes talking about just a few of the particular AI bright spots and dark spots. We already talked about one bright spot, which is great engagement with these AI tools, and another being knowledge integration. Okay, a particular dark spot right now is that basically AI, the web to some extent, but really AI systems have just completely broken the how we assess students. And if you think it isn't broken, you should go talk to your students and find out. And so they're just tremendous academic integrity issues, whether students intend to tend to not have academic integrity, or they intend to or not. It's just too tempting to use these AI tools in order to in order to learn, and also in order to work on your help solve your assignments, right? And so this is really a dark side, and we'll talk a little bit more about this in a second. But I think the bright spot here is that given that assessment is just fundamentally broken, we should all be spending our time, we should be spending as much time as we can thinking about like new ways to assess, more authentic ways to assess. And it could actually be that while AI is, one of the things that broke the current ways we assess, it could actually turn out to be a really powerful tool for like completely new ways of assessing students, right? Completely new ways of like continuously measuring, tracking learning, giving continual feedback to students that will actually make the system like better, right, than it ever was. And so I think this is a particular bright spot, but there's just tremendous work that has to go on in this particular direction. And speaking of academic integrity, which is kind of related to trust, there's all kinds of trust issues. Uh, Instructors increasingly not trusting students, and increasingly students pushing back, saying, "Hey, if I'm not supposed to use AI for my, as I try to learn, you, professor, shouldn't be allowed to use it either to create instructional experiences," right? And so we have sort of a lack of trust on both sides that really needs to be, really need to find some kind of common ground. And so if we come back to our, requirements that we were, just speaking through, just, two other really important elements that we need as we develop these, next generation teaching and learning systems using AI, is really how to keep the instructor as a really important part of this feedback loop, right? Have the actual experiences that students are seeing not just be totally random, right? Total, we'll talk about it in a minute, but just some kind of AI slop just generated by some tool, but really something that the instructor has curated. Really, they think that this is going to be really useful for their students, and also something where hopefully the instructor's voice can really come out, right? And this is something that's actually really, some people are really scared about this. Some people are really excited about it. But it's, the fact that you could, if you upload your persona, your pictures of you, right, and your voice to some of these tools, you can actually create Gen AI teaching experiences that are actually you teaching the students, right? Which kind of seems on the one hand super exciting and interesting and could be really engaging and keep instructors really key, also super scary. So all kinds of issues that have to be dealt with. So one of the reasons why it's super scary is that you could think, well, wait a minute, instructors, like, are instructors going to go the way of the dusting robot, right? What is going to happen to instructors? And to this question, I'd like to just tell a really interesting story, about radiologists. Okay, doctors who read X-rays and MRIs. And let's go back a few years, 2016. Jeff Hinton, Mr. Big in AI, the godfather of AI, had a quote, right? And I'll just read it. "We should stop training radiologists now. It's just completely obvious that within 5 years, deep learning is going to do better than radiologists," right? So he sounded the alarm, right? Way back then, about how some people in these, key, high skill jobs, that the days that their days were numbered. Okay, so let's go forward 9 years. Okay, and just a really interesting article in the New York Times said that in fact this has not happened, and in fact what has happened is that we now find radiologists working in teams with AI systems. So it's like an AI human team. As a result, the radiologist efficiency has gone way up. The actual accuracy of the reads looking for bad stuff in X-rays, MRIs, CAT scans has gone way up. And moreover, if you look at the Mayo Clinic as one example, the actual number of radiologists has grown. So AI, in fact, didn't like reduce the number of radiologists. It actually grew the total staff, right? And not only the total number of radiologists, but they built basically an entire team who could lever AI in order to improve and really consolidate the gains of AI in radiology. So this is a really interesting kind of I think lesson that it could be in the future that actually instructors are even faculty members are even more important than ever, right? But what they're doing is a different kind of task than they are today. That they're part of a human AI team to instruct students rather than just human to human interaction. Okay, so that's I think quite an interesting thing to think about for the future. So now let's come back to this um, another low spot, dark spot, uh, and that is related to what we talked about a little bit earlier, and the idea of the attention crisis, the fact that students are finding it increasingly difficult to concentrate, uh, their attention span is lower. And we know that when new tech comes along that can allow people to offload some of their cognitive load, humans tend to adopt that really, really readily. Okay. And so what we're seeing is an increasing cognitive offloading of kind of important key tasks that our brain in the past used to have to be really good at, for a great example, reading a map, navigating on a map, right? This kind of task is being offloaded increasingly to navigation apps. And there's actually research out there that's actually showing that humans, spatial reasoning capabilities have actually gone down because of the reliance on these kind of maps and other kind of autonomous navigation systems, right? And this idea of offloading, cognitively stressful tasks to technology, in particular AI, is completely at odds with the productive struggle that we know humans need in order to learn. You don't learn by just pouring knowledge into your head. You actually learn by struggling with ideas, right? And so we're moving into a world where humans are going to need to struggle less and less. And this, there's just been a lot of articles out there. This one's literally from just a couple days ago around how this could lead to a large scale cognitive decline, kind of anti-education, right? Not just in individuals, but across the entire population. And I think that this is something extremely alarming. Let me just talk about a research study that was really the inspiration for this Guardian article. Researcher at MIT hooked up people with electroencephalograms, basically measure their brain waves, right, their brain activities, and then they had two groups of students. She found students who were writing, let's say, an essay, okay, and then they were and they were just them and their laptop, not connected to the internet, writing an essay. The other group had access to search engines and to ChatGPT in order to help write their essay. Well, she actually found a significantly less brain activity in the students who were, or the people who were writing the essay with ChatGPT and search engines help, right? Less brain activity also means less learning actually happening, right? And I think you can read that last sentence, just really scary, right? That basically much less is happening in your brain when you're using these AI tools because there's no productive struggle, right? Add to that, compound that with this just exploding amounts of uh, what is termed AI slop that is now taking over the internet, right? By some estimates, over half of the internet is now AI generated content, not just videos, not just images, but text. And we're going to be increasingly inundated uh, with material that is not geared towards actually, moving instruction or education or society forward, but just basically, this a crazy, surreal world of continual kinds of entertainment. And so if we go back to our set of requirements, we see that not only as we design systems like this, do we need all of these things that we've already talked about, but we need to find ways to create AI systems that really create productive struggle for students and kind of invite them to that into that and actually it has to be engaging for them to do this. We also need to develop systems so that students are really having their critical thinking skills exercised, right? And we need to like guard against slop of all kinds in education. And so I think you could kind of summarize by saying, we're just moving into a really interesting time in education. And I think looking back, a few years from now, I think we're going to see the education world being really substantially changed, hopefully for the better. Okay, so all this talk about AI in education, you could build, presumably these great systems to do it to augment education with AI tools. We can, have all kinds of AI-driven teaching innovations like personalization for different students. Okay, but then we get into just a really important question of, do these teaching innovations, like, are they going to lead to learning innovations, like, or learning progress? Like we don't know. Like we have no idea whether any of this stuff works, right? Whether it's just, you know, works as well as the status quo, works better, or actually drags students down, right? And works worse. And so, it's really critical that we develop methods, right, to be able to figure out, not just with AI driven ed tech, but just any kind of new educational innovation, in general. Just figure out, what works and what doesn't. And really, the only way to do this is by measuring, right? Is by measurement. And because you can't, if you don't measure phenomena, then there's no way that you can improve those phenomena. And so, what we really need to do is to think about ways that we can make measurements about students, right, while they're involved in learning activities, right? So that we can hopefully, from that data, be able to understand better about what's actually going on in their mind, right? And also be able to understand whether the educational experiences they've been just interacting with are actually moving their mind forward or moving their mind backward. And so, what we really need to think about is as we're developing all these different tools that I've just been talking about over the last like half hour, we really need to think about how we can add in like measuring infrastructure, right? Now, the difficulty though is that human learning is like extremely complex, right? And it's contextual, right? It's like in the moment, and it has many different aspects to it, cognitive, behavioral, social, right? And just to reinforce how complex and contextual it is, here's a gratuitous block diagram of just all the different factors. Well, actually, just a few of the factors that all interact together, right? To determine whether a student actually learns something or not. Okay. And so what we need to do is we need to acquire data somehow, right? In order to be able to, you know, from those measurements, right? Be able to like understand what's going on, right? Along all of these different axes, right? That are in this block diagram here. Okay, and so we've been thinking about this for the last few years, and we had, things started with an idea of, well, wait a minute, we have our OpenStax teaching and learning platform and our digital textbooks. Maybe we could instrument them, right, so that we can acquire data as students navigate through our digital textbooks and other learning experiences. And from that data, we can use that data to be able to do like research and to understand, what's working, what isn't working, what's going on inside students' minds. And then we realized, well, it's not enough to just instrument our OpenStax digital textbook, like in the upper right here, because that only sees, it sees a sliver of a student's learning experience, right? Just, while this student is in our physics textbook, we get to see, the pattern of correct and incorrect responses, right? But we don't know anything about their background, their demographics, their transcript, how they've done in other courses, what courses they're taking at the same time, right? And so what we realized is that we needed to develop like a kind of like a hub that could pull together, right, information from multiple different digital learning platforms so that we can get not just a sliver of see not just a sliver of student learning activity, but a much more full picture. Okay, and this is something we've been working on for a number of years, and we realized very early on that that there's a real key issue here, and the key issue is that um, it's absolutely critical to think about like privacy, right? Because all of this data that would be generated by all of these different digital learning platforms is extremely sensitive. And so we've been thinking about ways that we can somehow, allow researchers to interact with this data, conduct learning experiments, figuring out what works and doesn't work, all while really assiduously protecting, right, the privacy of that data. And so we came up with an idea where rather than uh, allow data to leave any of these digital learning platforms, actually the data is remains locked down inside these digital learning platforms. But then researchers rather are able to send in research queries, like in the form of code, right? Software into these platforms in order to, for example, analyze data, do regressions, figure out factor analyses, etc. And then only the answers or results flow out. And those results are, inherently protect the privacy of the all of the folks inside these digital learning platforms. So that's an idea we had a number of years ago. We were able to convince the U.S. government that this is uh, a good idea, and the U.S. National Science Foundation funded a project that we now call Safe Insights to build a national education research infrastructure for digital learning. So it's a collection of now 13 large digital learning platforms. OpenStax is one of them. Western Governors University in the United States is another one. Some big learning management systems. Arizona State University Online, and then a number of K-12 initiatives. And these digital learning platforms every day serve tens of millions of students. So the really great thing is that there is going to be large amounts of data available for researchers. And the reason we need large amounts of data is because learning is so complicated. Okay, and because it's so complicated, you need large data sets in order to peel apart, right, the complexity of the human learning experience. And so that's exactly what we're aiming to do with Safe Insights. Safe Insights is a open science platform, right? All of the code is open and available. It's open to a community of all researchers, not just a few researchers, but all researchers. And the idea here is to really open up the community of researchers who have access to this scale, this really gigantic scale of data from the few dozens of folks who have access today to really thousands of researchers will be able to run learning studies on safe insights. Uh, and kind of, really exciting to us that in about a year, this project will actually be operational. And so if you're a learning researcher on the call today, it'd be great to chat with you, and I'll be able to send you, updates on when you'll actually be able to get your hands dirty in OpenStax. So hopefully this has made some sense. The way that I kind of put all of this together in my mind, as far as like how we're doing things at Right with OpenStax, is that we're really envisioning a stack, right, or a layer cake, right, based on this open education knowledge base, right, at the bottom, in our particular case, OpenStax. On top of that, really powerful AI teaching and learning tools that we can use to make educational experiences more, effective, more efficient, try to get around this attention crisis. But then at the top layer, an envelope of a research infrastructure so that we can continuously monitor what's going on in this system, right, with millions of students all around the world. And then we can use the insights that we garner from the research in order to feed that back, right, to develop better content, new kinds of learning experiences, better AI tools, and like a rapid cycle test framework. And with ultimately the goal so that we can scale these ideas to reach all students, right? No matter where they live and no matter where they're studying. And hopefully these open tools that we've been developing and the community have been developing are going to really help us scale up this kind of endeavor really, really rapidly. And would love to hear your questions and just come learn with us. Thank you.